Hello, and welcome to our first module on valence shell electron pair repulsion. So we will be talking about the Vesper theory. And basically, what we do when we talk about applying the Vesper model to molecules is we principally are trying to minimize electron pair repulsions. And so our bonding and our non-bonding pairs will be arranged around a given atom as far apart as possible. This is used primarily to predict approximate molecular structures. Those are just three-dimensional arrangements of the atoms in a molecule. And the different types that we'll be discussing today, but they're the most common types, are the linear structure, trigonal planar structure, tetrahedral, trigonal bipyramidal, and octahedral. They all have different bond angles, and they all have different steric numbers as well. And that's just how the electrons are arranged around the central atom. So there's a problem-solving strategy that we use in order to apply the Vesper model. We draw the Lewis structure first, and that is very important because we want to make sure that we have all of the valence electrons properly placed. We count the electron pairs and arrange them in a way that minimizes repulsions. We also determine the positions of the atoms from the way the electron pairs are shared. And then we determine the name of the molecular structure from the positioning of the atoms. So these are the arrangements of the electron pairs around an atom and how they look when they are minimizing repulsions. So if we have two electron pairs, then the steric number is 2, and we have what's called a linear arrangement. If we have 3 electron pairs, then we have a trigonal planar electron pair arrangement. If we have 4 electron pairs around the central atom, then we have the tetrahedral arrangement. If it's trigonal bipyramidal, that means that our steric number is 5, and we have 5 different atoms attached to that central atom, and the arrangement is trigonal bipyramidal. If the steric number is 6, that means that we have an octahedral electron pair geometry, and this is what our molecular geometry will look like. So there's a difference between electron pair arrangement, electron pair geometry, and our molecular geometry or our molecular structures. So when I say electron pair arrangement, I'm usually referring to the steric number. That steric number tells us how many bonding as well as non-bonding pairs of electrons are around the central atom. In this particular arrangement, we have a tetrahedral structure because we have 1, 2, 3, 4 atoms that are attached to the central atom. And so this is the tetrahedral electron pair arrangement. Its molecular structure and molecular geometry is also tetrahedral. However, if we have bonded atoms to this electron pair arrangement, but then we have a lone pair, that changes the molecular geometry or the molecular structure. Now, our molecular structure is just based on our bonding pairs, and we call this trigonal pyramid. If we have 2 lone pairs and we have 2 bonding pairs, then we just look at the bonding pairs and we have what's called a bent arrangement or V-shaped. Here's another example with a steric number of 5, where there are 5 electron pairs that are around the central atom. If we have 5 electron pairs around the central atom, then we call that molecular geometry trigonal bipyramidal. If we have 1 lone pair, and we're now looking at just the bonding pairs, the electron pair geometry is still trigonal bipyramidal, but our molecular geometry changes to what we call the seesaw. And if you look here, it looks just like a seesaw. If you look here, we still have a trigonal bipyramidal electron pair arrangement, but now we have 2 lone pairs and 3 bonding pairs. And so if we look at our bonding pairs, we notice that our molecular structure has changed and is now T-shaped. If we have 2 bonding pairs and then 3 non-bonding pairs, that means we have 3 lone pairs, then our molecular geometry changes to linear. So what is your challenge today? Today we're going to work in groups. So you're going to get into groups of 3. Each group will take a molecule. I have placed the name of the molecule alongside the room in the starship. And you will take those molecules and you're going to use spheres and lines that are available in your IFX imagery. And you're going to create the molecular geometry for the molecule. Once you're finished, you're going to discuss not just the molecular geometry, but also you're going to talk about the steric number, the electron pair geometry, the molecular geometry, and the bond angles that you have had to fixate the molecule into in order to minimize repulsion. Once your group is finished, then you can feel free to walk around to other groups that may have more complex molecules than you do. And you can lend a little bit of your expertise, especially if you've mastered how to then move your molecules in your headset better. After that's done, I will summon us all together as a group, and you will present your class the molecule, and you'll talk about all of the things in step 3. I wish you the best of luck, and I'm excited to see what you present.